Okay, so it's 2:30. I will go ahead and get going because plenty to talk about. So my name's Billy Korando, and this is to Java 21 and beyond. Initially, when I submitted this presentation for Spring IO, I was going to do to Java 20 and beyond because we haven't actually entered ramp down phase. So technically, some stuff could still be added to 21. But Sergey's like, you should really do Java 21. It's going to generate a lot more interest, and does seem, good amount of people are showed up. And I'm glad he did. There is definitely a lot to talk about. But then I'm also kind of a little upset with Sergey. I had to kind of rewrite this presentation largely because there is so much coming into Java 21. So yeah, Sergey maybe end up working more. And I just hate doing that. But yeah, this is really interesting. Java 21 has really increased in size, and there's a lot of interesting to talk about. But also, if you want to find me on Twitter, where I spend too much time, you can find me at Billy Korando. Some very important information, though. Please ask questions. If at any point during this presentation you want me to go a little bit more in depth on something, raise your hand, ask, and I'll be more than happy to try to give you an answer. But if there's later on you want to ask a question, again, you can reach out to me at Billy Korando on Twitter, shoot me an email, billy.korando@oracle.com. If you want this presentation, it's live right here at this URL. In fact, if you think it's going too slow, you can just go to this URL and just skip ahead. Be like, it's just, give me to the cool stuff like Loom or something. You can feel free to skip on ahead if you go to that link. And if you would like to know more, so I'm part of the Java DevRel team at Oracle. You can check out dev.java, where we have a bunch of tutorials and stuff on various Java topics, of course. Insight.java, where that kind of focuses on like the engineering of how the JDK is made, and so that's another great location. And of course, we have our YouTube channel where we have things like the Inside Java our Inside Java podcast, and Inside Java newscast, and a bunch of other great shows and content as well. So the agenda, the big change I had to do is that, now I really can't spend too much time talking about all the changes between JDK 11 and 17. Actually, so if you're on JDK 8 or above, put your hand up. Hopefully everyone, okay. Okay, are you JDK 11 and above? All right, JDK 17? Good, wow, okay, cool. So, awesome. So some of this will really be review for you, but hopefully also you might learn a couple of things even during this review section. But I do want to put it in there because it builds important parts for what's going to be coming in both 21 and beyond 21. So some of the key changes between JDK 11 and 17. The first is text blocks. These were added in Java 15, and the JEP for this is 378. JEP stands for JDK Enhancement Proposal. So whenever there's a somewhat larger change that's being added to the JDK, it goes through the JDK Enhancement Proposal process. And if you go here to openjdk org JEPs /JEPs, then that'll give you a list of all the JEPs out there. And so like I did 378 for text blocks, and if you put that into the URL, that will give you the JEP for that feature, and that gives you a lot of the history, background, description of the change as well. Much more detail that I can give on all these changes during this presentation. So if there is some change you really want to go in detail on, just check out that JEP, and that will give you a lot of the background and how to use that feature. All the same, JEPs, that was added in Java 15, and of course that introduced two-dimensional strings that also reduced formatting, and that was very nice for if you're doing things like JSON, SQL, HTML, and so on. Now you're putting that into your code is no longer a mangled mess where you're constantly having to pin stuff together. Awesome. Switch updates, that was added in Java 14, JEP 361, and that introduced the new arrow syntax, which no longer has the fall through by default, which makes writing switches a lot cleaner looking. In this case, this is a statement. And then it also introduced switch expressions. And of course, most of the time with switch expressions, because they'd be exhaustive, they will need a default case, and we'll see a little bit also how that is going to be changing pretty soon in JDK 21. Seal classes, that was added in Java 17, Java 409. Seal classes allow you to define or allow a class to define who can extend off of it. Right now, again, this feature, it's interesting. It's a good way of communicating certain domain-specific information. Not quite super useful as of JDK 20, but again, going to become much more interesting in JDK 21. But we have sealed, non-sealed for basically a normal class or a final class where nothing else can extend off of it. And then also maybe something if you've tried to use seal before, permits is optional. And so if you're referencing, or if the classes that can extend off of that sealed hierarchy are in external code files, you have to use permits. If they are defined within the same code file as it is here with admin, then you don't use permits. And then only the classes that are defined within that same code file can extend off of that sealed class. Records, that's maybe one of the more cool language features that were added between 11 and 17. And at the easiest level, this definitely reduces the amount of boilerplate you have to write. But far beyond just that, it's a transparent modeling of data as data. You can just look at the definition of a record, and you know all the components for it. And then that that because it has to be the superclass is always going to be record, can't be extended, implicitly final. They're shallowly immutable. And you can't declare instance fields, and things like accessors, hashcode, toString, equals are automatically generated for you. Finally, also pattern matching for instance of. This is the first of the examples for pattern matching that was added to Java, but by no means last. That's a story that's definitely expanded recently. But yeah, that's introducing concepts like the putting together a predicate. If the predicate matches, then it will be set to this pattern variable, and this pattern variable is flow scope to wherever the compiler definitely knows this has been set, then that is available. And we'll again see how this is a very beneficial way of working with pattern variables, again, when we see some of the other examples of pattern matching that have been introduced recently. API updates, but the only major one was the enhanced pseudo-random number generator. So if you've ever had to work with random or creating a random number before, and you maybe wanted to use different implementations, they all kind of did the same thing, but their APIs were just a bit different. And in JDK 17, we have a much more uniform API that makes it a little bit easier to work between the different random generators. But if you want to know more about all the API changes, far more than I have time to go into during this presentation, the Java doc, if you go to this link, I know this is for JDK 20 because JDK 21 is still in early access and its link's completely different and harder to work with. JavaDoc has been updated to where you can also see some of the new changes have been added between each release, and that's really good to kind of see some of the recent changes, especially been like jumping from like 11 to 17 recently. You can see a bunch of the changes that have been added. Certain classes like string have seen a lot of updates to it over the recent releases, so definitely check that out. It's very helpful. A number of new runtime features. ZGC was introduced in JDK 15. And it's definitely a great garbage collector if you need very low or ultra low latency and are working with large heaps. ZGC is definitely a good option. If you're doing web applications, you probably should give it a shot, just because often with a web application, you do want as fast as response as possible. So if you're not ever having much latency because of garbage collection, that can help improve your response time. And then also you're going to be working with a lot of threads, which often leads to higher heaps, which again, ZGC excels at. So definitely check that out. Currently single generation, but we'll see it's soon going to become multi-generational. Also, I put together a truly fantastic video, if I say so myself, on ZGC that I released a couple of months ago. So if you kind of want to understand some of the underlying architecture for ZGC, check that out. Helpful null pointers. Of course, I think everyone is pretty happy with that because we all love null pointers, especially when it points you to just a simple line saying, hey, one of these three variables could in fact be null. Now, helpful null pointers will actually tell you what exactly was null on that line. And now, ARM Architecture 64 support is covered for all the major platforms. And then lastly, some of the deprecations and removals. Security Manager. Who here has used the Security Manager? one person or two people, okay, but primarily security manager is around to handle the applet API, because with the applet API, you could have like this, because right now, all the code that's running on our JVMs is code that we built ourselves. Like we either brought in libraries and built it and deployed it. And of course, you can do static security analysis on those libraries you're bringing in. Applets, back when they were, actually a thing, could be this extra code that you're bringing in to run in your JVM. And in that case, you would want the security manager to say like, hey, this package, we're going to give it a little bit less of security privileges because we don't know where it really came from. But with applets going, out of the program or out of the Java language, that kind of removed the one real need for the security manager as well. And then removals, Nashorn, and the CMS garbage collector. And then lastly, we're continuing that story of encapsulating the JDK that started with the introduction of the module system back in JDK 9, and that's continuing on to where you no longer can just have open access to everything anymore. All right, so that kind of covers all the stuff between JDK 11 to 17. If you're on JDK 17 already, obviously that was a lot of review, but I just want to kind of level set because that leads into a lot of the things that are coming in 21. As I mentioned, the pattern matching story has really expanded with JDK 21 with the introduction of pattern matching for Switch. And so pattern matching for Switch, Switch patterns that use pattern matching, they must be exhaustive. And also, for the first time, Switch can properly handle null as well. So here we have a simple example with like an interface of class, and that's being implemented by a few classes, triangle, circle, and square. And we can see here in the switch where on case triangle, we give it T, and then we can give a guard condition to where if the area of T is like over 100, then we do something else. This is a lot cleaner than having an if statement within the case to say like, okay, if this, do this, and then something else, because that can just become very messy very quickly. And then, of course, for a triangle, if anything's less than 100 units of whatever it might be for a triangle, then we can just do something else with it. But you would also notice how T here, I'm using it in both locations. For the compiler, those are separate variables. And that's because, again, flow scoping, T is only in scope to compiler wherever it definitely knows it is been set. So for that case, this instance of T would only be in scope for the actual case statement for that. But for here, it would be a separate instance of T. And that's kind of nice just so you don't have to arbitrarily think up new variable labels for these. You can actually reuse something like T for triangle because that fits it really well, and not having to come up with like X, Y, Z, and I, and all that stuff, which could become potentially very annoying. But then we see also circle as in doing that. But because we're doing pattern matching here, it has to be exhaustive. So fairly often that will mean you'll need to have a default case. We can also see here, we can also add a case null. So instead of just simply throwing a null pointer exception in the case that shape was null, we can actually properly handle that with something else. In this case, simply just printing out oops to the console. But of course, probably you'll want to do something a bit more interesting than simply saying oops if you run into a null. But all the same, much better than having to handle or just getting a null pointer exception. So I showed earlier how we have sealed classes, and now we can actually see some of the first real benefits of creating a sealed hierarchy. So I created a sealed interface hierarchy for shape again, and then I have triangle, circle, square, all of them implementing shape. And so the compiler can actually read and understand that, okay, because this is a sealed hierarchy, it's using shape, and then all these cases cover triangle, circle, and square, I no longer need a default case because there's no other options for it. And so not only, is it nice not having to put an arbitrary default case, if you were to add like a new shape to this oval or rectangle or whatever it might be, you'll get a compile error. So it's actually even safer code. You're not going to all of a sudden add a new shape, forget to add like update one of the sealed high or a switch case someplace, and then suddenly start introducing a bug because you forgot to update one of them. If that was the case, you would start to get a compiler error, which is one of the nice things. It's one of those ways where it's not just like reducing typing that you need, that it's actually creating safer code for you as well. The other major language feature is the introduction of record patterns, and their JEP is 441. Again, records have been really a great addition, greatly reducing the amount of typing we would have to do when defining a data object. But now, when we actually need to get values out of it, it's even easier. So here we are seeing an example of using the instance of pattern matching, and if it's an instance of name, we can also then just kind of create, almost looks like a little bit like a constructor, but now really a deconstructor for this record, where we can just define the different pattern variables. And in this case, so we have like our record that has like first name, last name, our first, middle, and last name. And really what I'm doing here, I don't necessarily I just only have to say a compatible type. And since I'm just doing var, that can be really any type that would match to it. And it's matching based upon the location that field is defined upon. So you don't have to match the actual names for what the record was defined in. You just have to match based upon the position that the record is defined in. But yeah, so we see here, we can just instantly get to the components, the fields of this record, and then reference them in this class or in the if statement to make it a little bit easier. And then we can also, the record patterns can even be put into the new pattern matching for switch. So again, if I was wanting to do a switch off of the name, I could do it here. And in this case, I'm going to be extracting all the values again. Oops, I do have a typo here. That should be middle name instead of M name or flipped. But yeah, if middle name is empty, then I will have one way of printing it. Or if it's not empty, I'll have one way of printing out the name. And if it is empty, then I'll have a different way of printing it out. But yeah, again, just that much easier when you're working with data to extract that information out. It's part of a much larger story that we're working on with Project Amber about what's called data-oriented programming. Brian Getz, the chief language architect for Java, wrote an article about 6 months to a year ago on InfoQ, kind of covering the vision that we've had for that. Oh, yes. So the question was, is the lowercase name? Okay, so yeah. So what's happening here is that I'm saying is it a type of name here? And then if it is matching on a type of name, then set it to the variable, pattern variable of name. And then from here, I am then referencing the fields of that name because it can detect that that's a record. So yeah, thanks for pointing that out. So yeah, that's how that's working, and that's why it works a little bit different from it up here with an instance where I can just directly reference the values of it. But yeah, so that's just setting it to this pattern variable and then destructuring it from there. But yeah, sorry, back to where I was. Brian Getz wrote an article called Data-Oriented Programming, and that kind of lays out the vision of where we're going with Project Amber. So like all these record patterns, records, and all that is all stuff coming out of Project Amber. And the goal of Project Amber is to make it easier to work with data because as we're moving away from truly large monoliths to I don't necessarily want to say microservices, but at least smaller services to where we're more often interacting at data boundaries, it becomes much more frustrating when you're having to extract data, pass it to a database, and then pass it back to somewhere else. Having to do a bunch of getters and setters starts to become a bit more of a frustrating behavior. Being able to just directly reference the values you want out of a record, or being able to switch on records and handle it that way becomes a lot easier to work with that data. And so more features are going to come that just further make that process even easier. We're still maybe at the mid stages with Project Amber, and there's still a whole lot more coming as well. There's been some more API updates though. Again, I think one that's going to be a lot of people are going to be happy with are sequence collections, and that's going to be introduced as an actual final feature with JDK 21, and that JEP is 431. So of course, we all work frequently with collections, probably most frequently as an array list. And so if you want to get the first item out of like an array list, that's pretty simple. You just do get 0. And if you want to get the last item out of the array list, okay, with a little bit of knowledge, it's like, okay, you get the size of you put like get, the size of that list -1 to get the last element. But like, how would you, if you wanted to go in reverse order through that list, so from last to first, how would you do that? Well, I mean, with a bit of work you could, but it's very difficult. So sequence collections will make this much more easy. So there's a new interface that's being added, sequence collections, and so one of the new methods is reversed, and that will give you a view of the underlying collection that's then in reversed order. So if you want to go from last to first, you can do that. And of course, if you wanted to add something at the start of the collection, or add something at the end of the collection, or get first, get last, remove first, remove last, now we all have those options, which will make it just much easier to work with, not having to remember that, oh, yeah, list our collections, they're 0 base, so you have to remove 1 from whatever size or something like that. It's much nicer. And that is also the new sequence map is also being added to give you some of the same abilities when it comes to working with maps. Yeah, oh, sorry.
Is there a reason that's a separate API? Why is map just not containing those methods? Why is it sequence map? Is that for compatibility or something?
So the reason why is just because, so the question is, why is this a whole separate new API, and why aren't we just directly updating the interfaces? And that is, I think, just to make it a bit easier for backwards compatibility. Backwards compatibility is always paramount within Java because Java, historically has been one of the most popular languages, in the world. And so there's already a huge existing code base out there. And so if we were to go through and directly update collection or map with those features, that could introduce some breaking changes. So it was introduced as a separate interface, and here we can see how that interfaces are being added within this hierarchy. So that way, if you're having some code that was like doing some reflection on a map, like, oh, get the third method within map or something like that, it's not going to suddenly break because we suddenly introduced some additional methods directly to that interface. So it's for backwards compatibility as to why that wasn't directly added to those interfaces. But yeah, we can see here, and I didn't get into sequence set because it's, I think, effectively just pulling down the references from sequence collection, but we just added it so that way it could properly get into the set hierarchy. But yeah, a lot of these methods are actually being pulled up from DQ into sequence collection. Yes? What would be the impact on performance? So doing like a reversed, so the question was, what kind of impact on performance would there be for collections? So like, yeah, if you're doing like underlying it, like if you're trying to get to the last item, like if you're calling get last from sequence collection on an array list, underlying it, it's still doing the exact same thing that you would have done of, calling size on that list, subtracting one. So there wouldn't be any difference in performance for that. If you're doing reversed, obviously there could be some performance costs in creating like that view and then going backwards through it. But again, it wouldn't be any much more of a negative performance impact than if you write it yourself. And if anything, probably a little bit better just because more time was taken to write the most efficient way of doing a reverse collection on a list or reversing that. So yeah, probably one of the biggest changes everyone here cares about. We're finally getting the first implementation, our first item from Project Loom in virtual threads that's becoming a finalized feature in JDK 1, and that is JEP 444. So if you're not familiar with virtual threads, like I said, first project Loom, and so what virtual threads are is they are a lightweight implementation thread model. I don't know what that was. And so what it is that it's decoupling the idea of a thread from like an actual platform thread on the operating system. So you'll have the JVM will manage the platform threads that are tied to the threads in the operating system. And when you're making a call out to some sort of service like a database or some sort of external web service that you're calling to do some sort of validation on some sort of object or just communication with, instead of having that block that thread the entire time where you're calling back, because in that you would only be doing like a few, like the CPU would actually probably only be busy for a few milliseconds as it maybe transformed that data into JSON and then called it out. While that's being blocked, the JVM can park that virtual thread into our, it can put, detach that virtual thread from the platform thread and then allow another virtual thread to then take over that platform thread to also then do some sort of CPU processing. And then once it gets a response back, the JVM can then reattach that virtual thread to the platform thread and continue on. Fundamentally, a lot of this stuff is kind of like conceptually similar to what it is with reactive programming. We have completable futures where you have a future that calls out and then, while that's working, you can process other features and then you'll get back to that, or once that future completes, then you can take the result from it and continue on. But the problem with the reactive programming is that it can be a bit confusing. You have like one thread that called out to that to make that call, and then you lose that context because then the thread's going to continue on to do other calls, and then you get an error back, and it's like, okay, wait, why did I get this null? Oh, okay, because this thread passed a null value to there, but kind of working that back through is difficult, and then also just how the code is written is also often a little bit confusing to look at. So you get a lot of the benefits that come from the non-blocking of reactive while still using the same imperative programming model that we're all familiar with. And then also you would continue to have that context where that virtual thread, that whole stack that comes with it will always stick with that virtual thread. So if some error occurs with it, then it's much easier to debug on it. So the other two big items that are part of at least the initial major trifecta for Project Loom are structured concurrency and scoped values. So structured concurrency, it will allow an easy way of breaking a task into smaller component parts that could be executed simultaneously. So like let's say my colleague Jose Palmard, in demonstrating this, like let's say you're building like a travel app. And for the travel app, you're going to call out to a bunch of like hotel services to find prices on different hotels. You're not necessarily going to need to wait, and like there could be like 5 of them. Maybe you don't need to wait for all 5 of those responses to come back. Maybe you only wait for like 3 or 4 of them to come back. You can use the structured concurrency block to say like, okay, call out to these 5 different services we'll wait for at least 3 to come back. Maybe you can wait an extra second beyond that to see if the other ones come back. But if nothing else comes back, drop out of that structured concurrency block and just take those results from that. So structured concurrency allows you to do that much more easily, to much more simply say, like, here's this block, and give it certain rules on how you want it to work. Or if like an exception happens for one, that's fine. We'll just take the results back from 2 of them or something like that. But it just allows you to much more easily break apart a process that can be done concurrently into those separate blocks. And then scope values is a way, so thread local, when we're working with potentially thousands of threads, isn't too bad. Most of the time, a value in thread local would be maybe only a few kilobytes. But with virtual threads, we could potentially have millions of concurrent threads on the JVM. And suddenly, if you're storing a bunch of stuff in thread local, that can start to have a pretty substantial impact on the amount of memory that your JVM is trying to manage. Scope values are immutable data that if you want to have it be shared across all of these virtual threads, you can store them in a scope value, and then all the virtual threads will have very fast access to that scoped value. And then that way it's also not being copied across all of those virtual threads, saving a large amount of memory. So for runtime features and tools, who here has heard of class data sharing or application class data sharing? Man, we just don't talk about it enough. And like there's like a big thing about improving runtime startup, which I understand is very important, but like, while this won't have nearly as great of an impact on improving your runtime startup as GraalVM or Crack, it's also vastly similar or vastly easier to work with. So what application class data sharing is every time you start up your JVM, the JVM is having to load a bunch of classes from the file system to then load into memory to then, of course, run your application. And of course, every time you're starting that application up, that process is being repeated. Of course, repeated processes are an opportunity for optimization, and that's what AppCDS is. So what AppCDS does is it says, when you start up an application, you can say like, hey, record all the classes that are being loaded and do that, and then put it into a pre-processed archive file. And then the next time, it will load from the pre-processed archive file, and it loads up much faster. So like starting up like a Spring Boot application, like I've done with like Pet Clinic on this like machine and stuff, and like it goes from like taking, I don't know, like 12 seconds to load to maybe like 8 or 9 seconds to load. So it's not like a huge benefit. And of course, how much benefit will vary depending upon what you're doing at startup. But, it's non-trivial improvement, and it's very simple. AppCDS has continued to improve to where if you're on JDK 19 or later, they recently added this auto-create shared archive to where basically it's like, it will look to say like, oh, does this foo.jsa Java shared archive exist? If it doesn't, create it. And then if it does create, or if it does exist, then load from it. But yeah, it's a very robust system that can just provide you a bit of benefit on reducing your startup time. And at this point, with JDK 19 or 20, it's just with one simple JVM command line argument. Huh?
Why would you not use it? Why is it?
There's really almost no reason at this point to not use it. And it's one of those, again, I don't know why we don't talk about it more. Because like, let's say like this file is, missing or corrupted or something like that. It doesn't depend upon it. So like if it can't load it or something, then it'll just fall back to loading from the file system, in which case, it just goes back to a slightly slower startup that you would have if you just weren't using it at all. So yeah, it's one of those like almost no point in not using it. I guess I would say like if you're running a container, like make sure it's like either referencing a volume that where this is would actually be, or when you're building that container, you have it start up to where that shared archive will be built within the container, within that image, so that it's available. Otherwise, of course, you're not going to get a benefit from this shared archive as it's working. But yeah, there's very little reason not to use it. And that's why I talk about it, because it's a really easy way to improve your startup. The simple web server. So if you just want to like kind of demo and test something out, the simple web server was added. In fact, I'm actually running this presentation on the simple web server. But what it does is it allows you to serve up static HTML from a file directory. So we can see that here, where I just have these presentations all loaded up in a file directory, and I just do JWeb server, and that way I have a simple web server that for serving some static HTML files, or in this case Markdown, that are processed with some JavaScript and to being presented like this. But yeah, pretty cool, and it just makes it that much easier if you need to do something like that. And then next, so I talked about GGC that was added in JDK 15. And then now in JDK 21, we're introducing generational GDC, or the very difficult to say Gen GDC. You know, mispronounced that plenty of times just because it's just all very similar sounding letters all together. But yeah, so other garbage collectors like serial GC, parallel GC, G1 GC, they're all generational garbage collectors. And what that means is that most of the time when an object is created within your Java application, it only exists for a very short amount of time, maybe a few milliseconds. And so generational garbage collectors, when an object is created, they'll put it into a Eden zone or a young generation. And the garbage collector will frequently scan these younger generations for objects that die, part of what's called the weak generational hypothesis, saying that most objects created will have a short life. And so it'll scan this area to say like, okay, this object you created is no longer in scope, and it'll remove it. So initially GDC was created where it was just all single generational, and it used some more complex algorithms, but generally you would have to scan the entire heap for stuff that would have to be removed. Now with generational GDC, it will act just like the other, or act similarly to the other garbage collectors. We'll have a young generation, we'll store stuff, and they'll get scanned more frequently to get removed. The long and short of it is that generational GDC will use a lot less memory, or should be using a lot less memory than single generation GDC, and it should also be more efficient with the CPU processing because it's not going to be scanning that entire region. So right now, if you want to use generational GDC with using JDK 21, you'll still enable use GDC, but then you'll also have to add this additional JVM argument of plus G generational to enable generational GDC. I need to go through and kind of redo the performance updates and comparisons, but again, with every release of the JDK, there's always going to be a number of performance improvements. I think JDK 17 or 18, like one of our engineers found a way to find string formats to be like 3 times faster. You know, that stuff adds up to where, you know, string format's a little bit faster, some updates to how the GCs work and here and there, and it kind of starts to add up to be pretty significant memory throughput and so on improvements, and just builds up with every release, and that all comes for free. And it's not even like you have to recompile your code to use it. You know, something compiled in JDK 17, as long as there's not any other reasons for it to be incompatible with JDK 21, you can just drop it on JDK 21 runtime, and it will get all those performance improvements for free. Some deprecations, removal, and some other changes. Yeah, really, actually, the only thing that so far has been deprecated is Windows 32-bit x86. It's going to be removed. So if you're still on Windows 32-bit, that's bad news for you. But obviously, we're removing it because not many people are still on that. All right, for the beyond. So we're going to look a little bit beyond what's come. Well, we're going to be looking for features that are either in preview or are going to be coming beyond 21. So unnamed patterns and variables. So I showed earlier about how like deconstructing a record pattern. So like let's just say really all I care about this is getting the billing address out of this record. It's very annoying that I still have to like care about the name, address, credit card number, expiration, so on like that. Now we're introducing unnamed patterns to where if I don't care about these additional variables, I just put an underscore to say, I don't care about these, and the only thing I actually care about is the billing address. And like underlying the JVM still is aware that those variables exist, but as far as programming is concerned, you don't have to worry about them. So we can see it here with unnamed patterns. Again, with like customer, I can just say if I just want to get the name out, that just reference name and give it underscore for that. Of course, it's based upon the definition of how that record is defined for the location of it, where you would put the underscore. We will also have like unnamed variables. So like here in the enhanced for loop, if for some reason I just don't care about the n and names, then I can just underscore it. Or more likely, like let's say an exception occurs. So like, age, it needs to be an integer, but I put cat instead for age, and that's not a valid age, obviously. I don't really care about the exception generated. I just want to give a response back. I can just say I can just put an underscore instead of having to define a variable that I'm never going to use. And again, it's not really maybe about saving typing. It's more about declaring, saying like, hey, don't worry about this thing because we're not actually going to use it. So it's a little bit better way signaling to future developers, we don't care about that variable. Again, mentioned structured concurrency. That's been promoted to first preview. It should be in JDK 21. It just hasn't officially been declared, but 90% chance that that's going to be in its first preview for JDK 21. And the same with scope values. That should also be in preview for JDK 21. Vector API. If you care about like things like image processing and certain kinds of math, you would care a lot about the Vector API. My history is kind of working as a web developer, and I've never used a Vector API, so I'm not very familiar with it. But all the same, it's in a 6 incubator, and obviously that's pretty high up there, but it's going to remain in incubator status until Project Valhalla, which is going to be changing like the memory model and variables and values like that. It's not going to get out of incubator status until Valhalla starts delivering, because Valhalla is going to fundamentally change how this works so much. So releasing it now wouldn't make any sense. So once Valhalla starts delivering, hopefully here next year or two, Vector API will start getting promoted into preview and then eventually a finalized feature. Same with foreign function and memory API, or sorry, not the same with foreign function and memory API. It's now in third preview status, and hopefully you'll maybe get to be finalized here pretty soon. String templates, that is some recent projects I was working on where I really wish we had string templates I could have worked with. It's going to be in its first preview in JDK 21. But what string templates allow you to do, here's a pretty simple example, is instead of like with string formatting, where you would just have to remember like, okay, I'm going to reference a string value, and you do like the %s or %i or %d, depending on like string, integer, double, and so on. Now you can actually reference specific variables. So now you can do that. So with string templates, it would also have a formatter here, which is what this str is. And the reason we went with that is because there's going to be so many different ways strings could be used. So like if it's just like a normal string here, fine, just replace it. It doesn't matter too much. But if you're doing SQL, well, obviously that could raise a risk of an SQL injection attack. So like if you're going to use SQL, you can do SQL here, and that formatter could make sure that you're not putting yourself at risk of an SQL injection. Did you have a question? Or okay. And so that's why we kind of went with that. And then also we went with like backslash and then curly brace instead of like something like $ curly brace, because backslash curly brace is an invalid character within normal strings. And so that's a way to signal to a compiler that, hey, this is a string template, not a normal string. So that way, if you try to use it in a normal string, you'll get a compile error. So you don't accidentally try to do that in a normal string. But anyways, here we see this example. And then, of course, that's the output it would give you, substituting the variables in that string for those variable, the actual values of the variables. Actually, one last thing that I'm really excited about, unnamed classes and instance main methods. So, it's probably been 15 years for myself, years for many other people here, probably for some people much longer. But yeah, when you're first learning Java, I kind of thought about just like, how do I first kind of introduce a new developer to Java? There's a lot going on here. We have introducing the concepts of like scoping with public, we're introducing class, we're introducing static, return types of void, arrays, arguments, and all that. That is a lot to suddenly introduce all at the same time. So we're looking at ways of simplifying an introduction to Java. So like now we can have just take away the need to have public in here and just simply have class. And also not to have public for a method, so we just have void. And further simplifying that, I have a typo here that should obviously have an enclosing parentheses. Yeah, that's wrong. Yeah, there should be an enclosing parentheses there. That's just a typo on my part. But then, so we can have that, and actually also you shouldn't need to have string either. So that's just a typo there. So yeah, you can even remove string args to where it just makes it that much more simple when you're learning Java. And we're also going to allow unnamed instance main methods to where you can just have an unnamed class and it just have simply main within it to run it. So for new developers, that makes it a little bit easier to learn Java. And it's good to have Java being more of a first choice for developers, both just wanting to learn and of course also for universities to continue to refresh the ecosystem of Java with new developers, but also for us older developers or ones that already coding professionally. This can make Java a more attractive tool for writing scripts and simple utility programs. I've actually started to use that a whole lot over the past releases. As we've added things like the ability to run a simple single program, a single file program with just Java instead of having to compile it first. So if you I'm terrible when it comes to bash scripting. Like I've tried it before, I learned it in college, and then I forgot all about it since then. So now if I need to have like a simple program that just takes a CSV file and spits it out or does something like that, actually Java is a pretty easy program or pretty easy language to use now for actually accomplishing those tasks. So it's not just something that can benefit new developers, but even more seasoned developers like ourselves. There are still some benefits as well. But this is part of a story called Paving the On-Ramp, about making it easier to learn Java. And so Brian Getz, again, wrote a really great article about that, and you can link to it here. And another change, a part of that, is being able to launch multi-source file code programs as well. That's currently at draft JEP, so I'm not sure when that's going to be introduced. Also, I guess I know probably one thing you're concerned is how will the JVM know which main method to use? You have public, the standard public static void main, and then you have in one of these other class hello world main. Will the JVM know which one to use? And there's an order of precedence. So public static void main will be the top of the order of precedence, and then from there on down, there's different order of precedence as to what the JVM will use first if it detects that in the class that you tell that's a main method. All right, and yep, that's it. If you want to check out all the JEPs, First link, the JDK 21 release notes. So it's a bit difficult to look at because with every new build, we'll kind of introduce the changes with that build. So it's a little difficult to look at right now. If you want to see what came in JDK 20 though, you can check these release notes. They're a bit easier to read. Again, check inside Java, dev Java. And I can probably remove this link because I think pretty much everyone's past JDK or on 11 or later. But if you're still struggling with that upgrade to 11, check out this article. But the longest short of it is, it pretty much comes down to just keeping your dependencies up to date. And actually, one of the sponsors, Modern, I know actually has technology or a solution for keeping your dependencies up to date. So maybe check that out as well if that's something you're struggling with. With that said, any questions? Yes.
Sorry, what's the timeline for the long-term support?
Sorry, what was the question again?
Sorry, when's it released, basically?
Oh, when is the release for?
I can't get a clear answer.
Oh, so when's the release for JDK 21? It's September 20th, something like it. It's in September. It's always, I think, the third Tuesday. Yeah. So back with JDK 10 and in March of 2018, we went to the 6-month release cycle. So every March and every September, we'll have a new release. Yep. Any other questions? All right. Well, if you have any other questions and you want to come talk to me, feel free to. Otherwise, thanks for coming.